Perspective. The appearance of near-far relationships due to line, shape, form, value, color, texture, and juxtaposition. The 6 ways that perspective is shown in compositions are size differences, overlapping, loss of detail as objects move into the distance, dulling of colors as objects move away from you, converging lines formed by objects as they move away from you, high-low position on the page, depending upon if the objects are above the horizon line or below the horizon line. Aerial perspective, or atmospheric perspective, is caused by the air. Light traveling through the air gets muddled, gets dirtied, is distorted. Thus, value of objects as they recede into the distance is changed, colors are muted, and details are lost. We see things along an imaginary line from our eye to what we're looking at. This is called our line of sight. Perspective is formed because of the change in this line of sight. These lines of sight go from our eye to the object through an imaginary window. We call this the picture plane. It is equivalent to the back of your retina. But if you think of it as a window, you can see how the lines of sight go through it at different positions. This gives us a distorted view of what the object really looks like. Here's a little example of a roadway that goes on forever. As you can see the line of sight going through the picture plane, it looks like it's at a point at one point and then widens until it gets to the actual size next to us. The point where objects appear to disappear or are foreshortened so much that they become invisible is called a vanishing point. Any lines that are parallel seem to recede into the distance, seem to be foreshortened, seem to be converging to the same vanishing point. As in this example, all the A lines all go back to the left vanishing point. All the B lines go to the right-hand vanishing point. That's because, in reality, they're all parallel. What we see of an object and what is foreshortened is dependent upon where it is positioned. There are 3 basic object positions: above, eye level, and below. The other thing that affects what we see is the observer's position. These are called bird's eye, normal, and worm's eye. Each one of these gives us a different view of the object and has different parts foreshortened. Why do we see things foreshortened? Now, I mentioned that we're watching things through a picture plane with lines of sight. The mechanical part of it is that these lines of sight come in at different angles, but they go through the lens in the eye and are projected on the retina. Now, if the angle is less, the image on the retina is smaller. So if an object is closer, it takes a greater angle of line of sight to see the top and the bottom. Thus, when it gets through the eye and onto the retina, it's larger. The things that are farther away, less of an angle, appear smaller. Here are 2 more examples of the same theory. D angle is smaller than C angle. F angle is less than E angle, so it appears like this. There are 3 basic linear perspective setups. The first one is one-point perspective. In this case, this being the viewer, this being the picture plane, one side is equal distance or parallel to the picture plane, and only the side edges here are receding into the distance. Here's our little man looking at the same box, with the front being equal distance from him all over. Only the sides receding into the distance. Here is examples of objects that are in one-point perspective with only one side receding into the distance and the front faces staying the same. Or an example of a road which only has one dimension. Or the tops of telephone poles. In this example of 2-point perspective, we now have our viewer, from the overhead view here, looking at an object that's twisted. In other words, no part is flat towards the picture plane, but this side gains distance as it goes along to the C measurement, and this side to the A measurement gains distance also. Therefore, there's foreshortening off to the right and foreshortening off to the left. Here's our little man looking at the box, the closest edge, and the receding sides. Here we have an example of a house, which is the same kind of thing, whereas one side recedes to the right, one to the left. The last basic setup is that called three-point. Now it's called three-point because there are three vanishing points. In this case, here's our observer. He's looking at the object. But as he looks at this object, the top is so far away because of its height that there's a difference between the distance here that's labeled E and the distance D. Therefore, as you see this object right here, not only does it recede off to the left and to the right, but it also recedes and gets smaller to the third vanishing point, which would be directly above your one-point vanishing point if there was one, directly in front of you. As you go farther into perspective, you learn about auxiliary vanishing points. These are needed when you have objects that are not sitting flat on the ground and have just vertical sides. For instance, here you have a box, the one we saw before, only this time it has a lid, and the lid is cocked partway open. Therefore, the angle of the lid is not flat to the ground plane, and it has another vanishing point above where its normal one would be. Auxiliary vanishing points are also used when you need to cast shadows, and you need the shadow to be in perspective as the object is.